Okay, great. Maybe they're not yet gone then.
All right, folks, if you can start taking your seats, we're going to get started soon. All right, let's get started. Good afternoon, everyone in Vienna. Good morning, good evening, good middle of the night, everyone at home, and welcome to Web Transport. This is our first in-person meeting since we formed the working group in March of 2020. We had an in-person BOF, and then we were virtual. So now you know how tall some of you are, and we're looking forward to seeing more folks at hopefully the coming IETFs. We still have a lot of folk remote. Oh yeah, and so my name is David Skenazy. I'm one of our chairs, and our other chair, Bernard, is here remote.
Hello.
Hi, Bernard. All right, the audio seems to be working well. So as a quick reminder, this session is being recorded. The usual tips for remote meetings haven't really changed, but things have changed for the in-person folks since we were last in person. In particular, if you want to join the mic line, you need to do it on the online version. Otherwise, you'll just be standing at the mic, stretching your legs. And you can use either the on-site or the remote version. They both work for that. And yeah, if you are in the room, like please join it as well, because that's the only way we populate the blue sheets, which is important. And then the buttons for Meet Echo are roughly the same. You press the hand to join the queue, and then you can unmute once it's your turn. Please stay muted until that's the case. All right, here are some links. The Note Well. It's Thursday, so most of you have probably seen it, but some folks might be joining for their first session today. So everything we do IETF is covered by the Note Well, and if you haven't read it, you really should do that. It said that you had to read it to register, so hopefully you at least glanced at it. In particular, anything you say has implications with regards to copyright and patents, and also the IETF has a code of conduct that the chairs will be enforcing. It pretty much boils down to be nice, which is what everyone has been doing in this working group so far, so we're really happy for that. Let's keep it that way. All right, some more links. We would like volunteers as usual for a Jabber scribe and a note taker. Do we have volunteers, please? Thank you, Lucas, for Jabber scribing. Who would like to be our note taker, please? I'm good.
Help with that, David.
All right, thanks. Bernard will help with that. Can someone from the room, Martin, could you perhaps help a little bit with Bernard since you're close to the mic? Do you mind? For taking notes. Awesome, thanks. And you can collaborate, both of you, on the usual thing that's accessible from the IETF agenda page. Awesome, thanks. All right, our agenda today is me talking for a while, that's done. Then we're gonna have a W3C update from Will. We are then going to talk about web transport of HTTP3 and then web transport of HTTP2 and wrap up. Would anyone like to bash the agenda? Consider the agenda bashed. All right, Will, let me hand to you slide control. There you go. Go ahead.
Okay, thank you. Just an audio check before I launch into the ether and nobody actually hears me. Is this okay?
Yep, we can see and hear you.
Okay, thank you. Good morning from California. I'm Will Law from Akamai. I'm representing the W3C group, looking at developing the API for web transport for browsers. I represent Yanivar Brewery, my co-chair. So just a quick update for you, 3 slides. Progress since November the 9th, last time we reported. The status of the spec is now a working draft. The latest version is March 11th, 2022, and there's a link in the slides here. You can go to it. As chairs, we've set a somewhat optimistic timetable for the year. It's outlined here with candidate recommendation coming up awfully quickly. The main blocker here is by July 31st, we had the idea for a proposed recommendation which requires at least 2 independent implementations. Chrome have been in production since M97. However, Mozilla have not yet signaled a date. So July 31st is somewhat challenged at this point, and I would encourage alternate browser vendors to Chrome to please step up here. We have a charter valid through September 30th. We will extend that charter if we're not able to get the second implementation in by that date. Milestones, we've adjusted our milestones to match the release process. So we have a new milestone up now called candidate recommendation. It obviously contains the issues that need to be resolved before we can proceed to that stage. Minimum viable ship, the prior one has a few issues remaining. Let me figure out how to advance the slides.
So there should be over the slides at the bottom controls for you where you can just hit next slide.
I'll just hit that one. Okay, Albert, thank you. So just a real summary of the decisions. I'm not going to go into details of all of these. Some of the resolution, establishing a session, clients should not be providing credentials. And I've got issue links there. You can go through and read the details. Blocking ports on Fetch's bad ports list. Adding smooth RTT variation to web transport stats with the definitions coming from elsewhere. Packets lost to web transport stats. Extra requirements on server cert hashes. On web transport get stats, we've added expired outgoing, dropped incoming, datagrams lost, and decided that stream stats will be an individual get stats method on each stream instance. And after some long debate, mostly resolved but not yet merged, we have some decisions around reliability and fallback, and also some good discussions about the actual state of the constructor argument, require unreliable versus request reliable, for example. Content security policy has also been a long issue. And there was recently a decision to break the compatibility with the early version of Chrome in the hope that it's better to do it now, as there's not that many users and that it would be more stable going forward. Datagram priority over streams, there's been a change. The priority algorithm had some guidance, and it's replaced with normative language that the user agent should make sure that datagrams get out quickly. The last one was very sort of absolute. Datagrams always go out first, and there was some potential issues there. Current issues under debate, bike shedding on names for stream stats, that should be resolvable. Connection pooling, there's new issues raised around whether it's default on or off and how to pose that in the constructor. And then lastly, priorities between streams. Is this necessary? And also, this is a question for IETF, is there intent to define a method of stream prioritization that might then filter down to the browser level that we could take advantage of? That concludes the summary from W3C. Many of the participants at W3C are on this call, so if there are any questions, we can take them now, or else back to David.
Thanks, Will. Does anyone have any questions for Will? If so, please join the mic line. All right. If you have something, Martin? Yeah. Oh, wait. There's a different Martin in the queue. I'm confused. What? Okay. MT, go ahead.
So Will's asking about priority here, which I think is probably one of the more interesting questions that we could discuss here. There's potentially something we could do. We could take the HTTP priorities thing and just sort of say, well, there's 8 levels and off we go. Or we could take a leaf out of the WebRTC book. I think they have 4. Does anyone want a bike shed on this one? I think it's really coming down to that.
Thanks, Martin. Martin? His joke never gets old.
When you say that 2 interoperable implementations are needed, does this mean that all the features that you just presented need to be implemented in those? For example, all the studs and the certificate hash and so on.
No, is the answer. They don't have to be precisely identical in feature set. I think there's an intent that they should deliver the majority of the capability, but Chrome has certainly shipped not with these features in, and that's acceptable. They're getting added post-ship. So I think the requirement is that we want basic functionality, be able to connect, be able to establish streams, send datagrams. That would be evidence of an implementation. I would think the stats could certainly be acceptable if they were not identical.
Thank you, Alan. And for folks, once you've put yourself in the virtual line, feel free to stand at the mic. That's okay.
Alan Frindell. With respect to priority, I think I like the HTTP scheme a lot in terms of the 8 lanes, and I think in terms of different priority schemes we've looked at least in HTTP over time, that this has got the right balance of flexibility, power, simplicity. And creating another one, I'm not sure would be really useful. So finding a way to adapt that as like a model. There's 2 pieces. One would be if WebTransport adopted it, would we add signaling to the wire protocol so that the browser side can set the priority on streams that the server is sending? And another one is just on the API side, can the browser set priorities on the streams that it is sending, which is strictly does not require wire format changes. It's just between the API and the sending implementation. Thanks.
Thanks. Just double checking. I'm not seeing any typing happening in the doc. Bernard, are you taking minutes?
The notes file, it's been acting a little squirrely, but I do see someone else taking notes there, so at least one other person has figured it out.
Well, I just added what MT had in there. Are we all thinking that someone else is taking minutes?
Well, I am taking minutes, as I said, in the notes file, notes-IETF113-Webtrans.
Oh,
notes.ietf.org. It's been acting weird, though.
Okay, yeah, I'm not seeing updates. Well, as long as you have them, we're good. All right, thanks.
Yeah.
Victor, you're next.
I was mostly under the impression that the priorities, at least outside of those communicated as the wire by HTTP, are typically considered to be an API concern. So I personally, unless we intend to provide a mechanism for end-to-end signaling, I don't think that there is much in this working group to be done. Since as far as I can see, it is mostly an API problem, as in it is about how web applications signal priorities to the browser's network stack and not to the peer.
Thanks. Martin Thompson?
Yeah, I'm going to agree with Victor here. I think that if an application wants to do the signaling, it can use WebTransport for that. That's probably the most obvious thing to do here. And then it becomes a purely API consideration. And I think, to Alan's point, the extensible prioritization scheme scares me. I think probably for something like WebTransport, the incremental flag would be on always, so we can at least make that simplification. And then it's just a matter of how many levels of priority or urgency or whatever it is that we have, how many levels are appropriate for this particular context. And I think that's almost entirely a Pike shed.
Okay, thanks, MT. And thanks, Will. I think we've cleared the queue. Thanks for the presentation. We're going to move on to WebTransport over HTTP 3. Victor, come on up, and I will transfer slide control to you.
Sure.
I see. Okay, 1 second. Revoke slides. Apparently I need to stop and represent. Share preloaded slides. Share. Pass to Victor. All right, you can control your... Oh, and we started from the start. Sorry.
Think that's the slides.
All right, go ahead, Victor.
So,
Thanks.
I'm Victor. I'm the editor for the overview and web transport over HTTP drafts, and those are the two drafts that are probably currently further along in the process, in the sense that web transport over HTTP has an implementation in Chrome, and we, to some extent, know it works, and we've interrupt with servers, and it's been used by people to interrupt with servers that were written by not us. But there are still a lot of unresolved issues, especially in the overview draft. So the overview draft was originally, it was written probably the first earliest in web transport process. So it is to some extent the least reflective of what's currently is. And the reason we so far have not paid much attention to it is that we were mostly focusing on getting one transport done. However, now that web transport over HTTP2 is moving along, we need to provide some form of abstraction between what web transport over H3 does and web transport over H2 does. And that is something I believe we should do in the overview draft, since it is well positioned to do that. I wrote up a pull request to do that, or at least some of that. This pull request defines all of the operations that are cited in W3C spec, except the W3C spec currently cites either RFC 9000 or Web Transport over HTTP draft for those, which obviously does not work if we want this to work for both H3 and H2. I encourage everyone to take a closer look at that pull request. I don't think there's much to discuss since it's mostly around the text. So now, Web Transport over HTTP still has a lot of some issues that are not resolved. And one of them is the question of whether we need to support a go-away-like mechanism for training sessions. And the reasoning behind why we need this in the protocol, as opposed we need it in the application, and the application can handle it by itself, is that the go-away can be not only sent by the endpoints, it can also be sent by a reverse proxy, which is going away, or some other element in the chain. So the proposal is to add a train web transport session capsule that can be inserted by anyone on the path. And do people have opinions about that? I know Alan probably has opinions since he proposed it. Do people want to say anything at the microphone?
Not seeing anyone get up in the room, Victor.
I see. Then the question would be, Alan, would you like to write up a pull request for this?
Alan says, sure.
In Shepard.
Alan says Sue. Okay, well, what are you trying to? No, no. All right, let the minutes reflect that Alan said sure.
The next issue is okay. Let's first issue 67 is a very closely related issue, but it's different. So for regular HTTP requests, the way go away packet works is that when we receive a go away, we're not allowed to create new requests, but the old ones still can finish. And we do not currently define for what we do with go away and web transport. And my current interpretation is that web transport inner streams ignores that limitations, but the new web transport sessions cannot be created. Do people have any opinions on this? On what should we do about this? Or whether we should change this behavior? Alan.
Alan Frindo. So I think when you think about it in the context of HTTP2, where all of the web transport streams are not visible at the HTTP session layer, you know, an HTTP2 go away would have no impact on whether a web transport endpoint could continue creating new web transport streams within that established HTTP2 stream. And I think we should preserve those semantics for HTTP3. So if you receive a go away, it means no new web transport sessions, but you can still create web transport streams if you want to.
Martin says in Jabber he agrees with Alan. Does anyone else has anything to say? Bernard? All right, it looks like we have consensus on that issue.
So to clarify, Victor, you what are your thoughts? Do you agree with Alan and MT?
Yes.
Cool, and I'm seeing another +1 in the chat. Cool.
That sounds. The next issue is issue 33, closing everything when ConnectStream closes. So our current behavior is whenever ConnectStream closes, everything in the session is considered to be closed, and we automatically just reset everything and reject all future datagrams. At some point, Alan suggested that we might want to keep the internal streams open, even when the sessions is closed. And when we discussed this a year ago, the conclusion was to revisit this once we have more implementation experience. And my current impression after having more implementation experience is that having the semantics where the control stream automatically terminates everything on session is much easier to follow and much easier to manage in terms of resource lifecycle. And also, if we allow that, I am not sure how that would look for HTTP2, where everything is on a single stream. So I think we should keep the current semantics where closing the connect stream automatically terminates everything. Do people agree or disagree? Eric?
I think I would generally agree with killing the connect stream, kill everything else. It seems like if you don't do that, what you're effectively saying is that's kind of an implicit, a couple of slides ago, the go away that we wanted for a web transport session. And so it seems safer to make that an explicit go away if you wanted those semantics, and then still have your control stream around if you needed control messages, rather than having the control stream disappear and trying to assign some sort of meaning to that.
Magnus.
Magnus Westlund Eriksson. Is this is it per direction or both directions? That this occurs that you close?
Currently closing in any direction results in it being considered terminated. So it is similar to how connection close behaves in Quick.
Okay. Yeah, I mean, it's depending on what protocols you're doing. In some cases, it might be that you actually want to finish saying. It's the assumption what if you're relying on the higher level protocol built on top of Webtrans or Webtrans itself to do the close, which kind of semantics you want. So it's a bit, yeah.
Well, the higher level protocol does not necessarily always close. If it's a pooled web transfer session, that just means that the one session disappears, but the HTTP free connection remains open.
Yeah, I don't know. Sorry, cut that.
Martin.
You're muted, Martin.
This is the risk of having 5 multiple different mutes on my end. So if we're thinking about the HTTP 2 version of this one, if you close the connect stream, you also have just shut off your ability to send any more stream data of any type. So I think you're also prevented from receiving it in a sense. Probably not. So I tend to think that once we've closed the streams, then everything else is effectively orphaned at that point.
I'm under impressions that David Skenazy.
Hey, Victor. Speaking as an individual contributor, well, rather as a Mask enthusiast here. In the HTTP datagrams draft that we have over in Mask, when you close the connect stream, you can no longer send datagrams. So my personal take would be it just makes everything easier if when you close the connect stream, everything's done.
I'm under impressions that we're all at this point agreeing that closing the connect stream effectively closes everything on the session, which I think is the current text of the draft. I need to make sure that this is very clear on this. But that sounds like we are good to just keep it as is.
Sorry, I forgot to end.
That's fine, but please state your name.
Yeah, Magnus Westlund. One question I have is about receiving the data. That if you're basically sending the rest of the data you have and then you hit close, is there a risk that the receiver will get the close before the other data is sent, and then you reject it? And I would be a little bit careful about that particular use case. What happens in that situation?
So there is in Web Transport I guess I'll just jump in, Victor, if that's okay with you, a closed session capsule that is the graceful close. So that's what you would do.
Yeah.
And so this is about, and then once all that is done, then you can close the stream.
Okay. Yeah.
To clarify, there are effectively 3 ways you can close the connect stream. You can close it by sending closed session capsule, which gives you the status code. You can close it by just sending thin, which is equivalent to sending an empty capsule, and you can reset. And this issue roughly covers all 3 of those cases. But yeah, in general, since the metaphor I'm using is connection close and quick when you close connection, you no longer care about any data that's being sent on the connection, except possibly for retransmitting the close itself. The next issue, and I think the last issue, the one I think deferred many meetings ago and nothing happened, so I'm bringing it here, is how do we handle L service header? The current answer is we de facto do not do anything with L service header, and there are two modes in which web transport can operate. It can operate in a pooled mode, and it can operate by having a dedicated connection. And in case of, and this is complicated that to some extent we have to do this for both, and for pooled, we have to be cognizant of what regular HTTP3 does. And one of the first questions I have before even discussing this issue is whether this belongs in the IETF draft or W3C draft, or this belongs in fetch. Martin.
Okay, so the easy part of this one is that if you get an alt service in your response, you still keep the connection available and carry on with the requests that you have open on that connection. And the web transport session will be just another one of those requests running on that connection. So in terms of the effect on a web transport session, it should be nothing. It may affect what the browser does with future requests, but that's not something that web transport necessarily has to concern itself with. The sort of broader questions about how does web transport interact with connections with all of this, I would just say, look, there's an alt service biz going on in HTTP working group at the moment, and let them sort it out. And when I say them, I mean it's Mike and myself, probably, but we'll see how that works out for us all.
I see. Does this mean we can so far close this issue on our side?
That's essentially what I was saying, yes.
All right. That makes things easier for me. Thank you, Martin. And I think this ends my slides. So.
Thank you, Victor. Eric, come on up.
All right. So this is still an HTTP3 topic as we go, but we're splitting some of this across H3, and then we'll also talk about H2. So let's talk about pooling. We have decided a while back that we would like to support pooling, and that means that we want to be able to have more than one web transport session within a given HTTP3 connection. And I've got a little side note here on the side that this is really not that much of an issue for H2, because each session is fully encapsulated within one connect stream, and H2 is already perfectly capable of having more than one connect stream. And so a lot of the layering there works perfectly well and is not a huge problem. But within H3, we've kind of got these native H3 streams that we're also using for web transport. And so we need to figure out how do we make more than one web transport session work. There's also another consideration which applies to both versions of HTTP, which is that we want web transport to be able to coexist with regular HTTP requests going over that H3 connection, not just web transport sessions. So coming back to the pretty picture that we looked at last time, this is kind of visually what we think we're doing, and we had this up in the context of flow control for H2. but essentially within HTTP2, every web transport session is within a connect stream, and you can have multiple of those. Pooling, done. H3 is a little bit more interesting because you have web transport sessions where here we've kind of broadened this box, and this is all a little bit abstract, so we don't need to get too into the details of this diagram. But what we're really trying to convey is that we've got these different native HTTP3 streams that are serving different purposes on behalf of that web transport session. And so if you want to have multiple web transport sessions, those are by definition going to end up using multiple actual H3 streams for the different web transport streams that go within those web transport sessions. Turns out we've actually got a bunch of different issues on GitHub for this. And there's been some interest expressed across each of them, which is nice that we're consistent, to essentially provide resource limits and not do a whole lot else. So the proposal that I'm going to make with these slides for discussion is that we do the necessary things in order to keep any individual web transport session from essentially unfairly dominating the H3 connection and call it a day. And explicitly, that means we're not going to do anything to try to preclude future enhancements to this. So as we discover other places where we need to do things, it would be great to do those as extensions, but we're not going to put any time and energy into them right now. And that would close all 4 of these different GitHub issues, which is a non-trivial chunk of what is remaining across the set of web transport repositories. When we say resource limits, we're effectively talking about flow control in its various forms. And when we look at that for H3, H3 is really inheriting that from Quick, but there already exists a way within a stream to limit the amount of data going by, and there's also a way to limit the number of streams that you can open. And so some of this is already taken care of, and in the same way that H3 inherits things from Quick, web transport can potentially inherit them from H3. What's left, though, is some sort of control on the maximum count of sessions that you can make, right? So if I wanted to open 1 million web transport sessions within my H3 connection, that might not leave any room for non-web transport requests to go on there. And also the count of streams for each session for the same reason. Because the streams are native H3 streams, those are kind of entangled. We do have a note in both H3 and also actually in H2 right now that says that we don't actually go out of our way to provide any limit on the number of web transport sessions that you can open, and that instead there's 2 different ways that the server or the receiver of that can just say, nope, this isn't happening, and I just reject it. So we could choose to say that is sufficient to qualify as a resource limit, and that's what we've done up until now. But we could also potentially, I think, without too much additional complexity, take it a little bit further. So one way to do that, and this part is strictly optional, especially in light of the previous slide, is to take our current switch for something like settings enable web transport and change it to be a setting like web transport max sessions or bike shed on the name at any point. But effectively, if you set that to 1, that has the nice property of saying I'm allowing 1 web transport session within this H3 connection. And if at that point, there's not really any pooling, if you set it to more than 1, now you have as many as you've allowed, and everybody's in good shape. The other places where we generally talk about flow control kind of follow this almost tiered layers on which you have limits for different resources that can be consumed. And this is very, very similar in shape for the way that we did this within HTTP2. It's also very similar to how it looks in Quick. And so in the spirit of maintaining similarity with that, making something that parallels that very closely for web transport seems appreciably nice. The layers that we have there are this total session count, which we've just been talking about, limiting the number of streams within a web transport session. And then we have essentially session level flow control for total data, and then stream level flow control within each stream. And this is very much the same pattern that we have elsewhere. The way that we generally do that, for example, within Quick, is we have a max stream frame that adjusts the limit on the number of streams, and then we have max data and max stream data. And of course, all of these have their associated blocked frames as well to help with debugging and other issues like that. We have this nice property here in which, because Web Transport over H3 is already using native H3 streams, those have a flow control limit on them already from Quick, which is that max stream data frame. So we don't actually need a new one there. That is already present. And if we do the max web transport sessions setting, then we don't need any other limit for total session count. That takes care of that. And so that leaves us with limiting the number of streams within a web transport session and limiting the total data within that web transport session. And it would not be particularly hard to do that with a web transport max streams capsule and a web transport max data capsule. If we go back to our pretty picture from before, I've added some vaguely shaped annotations to kind of try to help visualize what this means. This may or may not be meaningful. If it is not, no worries. So the first one is down at the bottom there. We've got our setting for max sessions, and I've put that around the fun little ... that indicates that you have more than one web transport session. And then within that web transport session, you've got a limit on the maximum number of streams that you're willing to devote to that web transport session as opposed to a different one. This is to basically allow you to portion out the stream limit that you have for the total H3 connection. And then within that web transport session across all of the streams for that session, you can do the same thing for the number of bytes. So you've got count of streams plus you've got bytes. This is going to be interesting, and we're about to have a discussion in a little bit about capsules for HTTP2, but it's worth noting that this looks exactly like the two capsules that H2 is already defining, which are coincidentally called Web Transport Max Streams and Web Transport Max Data, along with obviously their blocked variants. So potentially, if we've already defined those and we've already got semantics for what they do, and those semantics match what we want, we could just use those in H3 as well. And at that point, we bring in those two things. We've answered as much of the pooling question as we're planning on answering. You've got the necessary resource limits in order to make sure that different web transports can coexist on an H3 connection, along with other actual HTTP requests. Everybody plays nice, and we are happy. Martin.
Having connection level flow control on the web transport level sounds like...
Sorry, Martin, talk a bit closer to the mic. We can't hear you.
Having connection level flow control on the web transport layer sounds like a pretty severe layer violation, since the web transport layer would now need to reach into Quick and ask how much data is buffered for any of those streams. Well, Quick is all about layer violations, so maybe we're okay with that. But I was just wondering if you have any thoughts on that.
I don't have a strong negative aversion to keeping track within a web transport session of the amount of data that you're allowed to send, and having a limit be communicated from the other end about that. But if it could also be that I'm not correctly internalizing how painful that would actually be. See, David is not standing up.
Yeah. Well, speaking as an individual participant, can someone perhaps kind of clarify? Because in my limited understanding, this can be done all at the web transport layer without having to reach down into Quick or violate layering. So can you maybe explain that a bit better?
Yeah, so of course you can read the data out of the stream and then have all your buffers at the web transport layer. So I guess my question is, how do we account for if there are missing packets or missing frames on a stream? So in quick flow control, then the maximum offset that you have received would count for flow control. Do we then say, like, we don't care about this, or we let the quick layer handle this, and we have like this totally separate flow control on the web transport layer? I haven't fully thought this through, because we are now reusing the quick flow control from the stream on the web transport layer. If there's any mismatch there, I would need some more time for that.
Thanks. Yeah, my and as an individual participant, like naive understanding was that this was a completely separate flow control, but again, not. Let's let MT jump in.
Yeah, so Martin's right. This is basically, I think it's near impossible to do this without major architectural contortions. I suspect that probably the right thing to do here is not deal with the session level data limits and simply say that you have quick level flow control acting on the bytes. Having a limit to the number of streams that you dedicate to web transport is still useful. It would be nice if we could stop web transport from eating up all of the bytes and starving out the other things, but I don't see a way to do that easily, and it makes me nervous.
So just to make sure I'm parsing what you're saying correctly, with this slide here, the first two items make sense, and I think those are all kind of fairly intuitive. And because we're able to punt the last one to just being Quick's actual flow control, that saves us from having that be particularly painful, but it's the one right above it that is exceptionally painful.
Yeah, I mean, I don't want to force a web transport implementation to suck all the bytes out of the streams in order to get that limit enforced, knowing that enforcement is going to be imperfect at that point. And I certainly don't want to have it with its tentacles deeply embedded in the quick stack in order to get the values that the quick stack is using. So I think I'm all for saying, just, okay, maybe we just don't do that one.
I think that seems reasonable. I see Martin is also
Go ahead,
on his
Martin.
way.
Yeah, max streams might also be a little bit difficult because you don't have stream IDs on the web transport layer. And so you would need some kind of stream counting that's synchronized between the endpoints.
Just to be able to keep track of them and know what's there. Yeah. In terms of not doing the max data side of things, I don't see a huge loss if we're not doing that, right? I mean, the reason we have a lot of those tiers is to allow people to be more restrictive and therefore allow any individual stream to use that entire limit without having to commit to using these, to being willing to devote the resources for the sum of all of the streams. But it's entirely possible that you can tackle that elsewhere anyway.
MT?
Martin's back.
So many mute buttons. I'm sorry about that. The max streams one, I think, would be an absolute number, right? So you would say, I'm dedicating 20 streams to each web transport session. We probably have to have some sort of minimum commitment for the purposes of like this. You must provide this many streams, but that doesn't mean that you're going to get that many streams. And so if you have an absolute, but you can just count how many streams you've got at the moment. There's a little bit of trickiness in terms of the accounting, but I think we can make that work. And of course, if the quick layer isn't able to issue new streams faster, then you won't be able to get up to this limit, but that's okay.
And for what it's worth, I think that's probably a good thing, in the same way that max data gives you, a way to say, I'm not willing to take the sum of all of them in total. I want something smaller than that. You could always say at the quick layer, I'm only willing to take this many streams, but each web transport session is able to use all of them, which does not then commit you to the sum of all of your web transport sessions in stream count. So,
Are you thinking about sharing that pool of streams between sessions, or is this a per stream one, or per session one?
No, it's just the fact that Quick has a limit on the max number of streams is essentially the shared limit.
Yes, yeah, that's right.
So at some level, that's almost a feature more than a pain point.
Agreed. I think we're going to want to try this out to be sure, though.
For sure.
Alan from Dell. So I think I hear the concern that max data is hard, maybe, I don't know, I don't want to say impossible, but much harder than stream. So I think maybe what makes sense is we separate this out and kind of table max data for now, but I'm left a little uncomfortable thinking that one session can cannibalize Quick's entire flow control and leave other sessions blocked. And so it'd be good to have a solution, but how complicated it needs to be, is it worth implementing? Maybe not. But I think I'm okay to move forward here. Let's just look at streams for now and maybe keep an issue open to revisit data, or have somebody sketch it out. What would it really take?
Jumping in as chair here, what I would propose as chair, assuming folks agree, is starting first with limiting the total session count via settings. My understanding from the room that I'm hearing consensus that that's good. If anyone disagrees, please come to the mic line now. Okay. Limiting max streams. It sounds like this might be hard, but we want to try. So I'm getting consensus. Let's write a PR to do this and have someone implement it and see from there. If you disagree, please jump up to the mic. I'm getting a sense that max data, most folks think that it's too hard, but Alan thinks it might be possible. I personally, as chair, I don't love the idea of keeping an issue open with no clear resolution point. So what I would suggest would be to close the issue. And if someone has a design that they've implemented that they want to bring to the working group to say, I figured out how to do this, please take a look. Can we put this in the spec? They could reopen a new issue at that point. Alan, would that be an acceptable resolution for you? And for everyone else, by the way, if you disagree, please jump up.
I'll just repeat what I said in the chat, which is I'm not any more sure than anybody else that it's possible, but I am interested in spending some more time, or having also the group spend more time exploring, is it possible without bending over backwards or doing something that's not worth implementing? So in terms of, I'm personally like to keep the issues open until they're really resolved, but otherwise it might get lost. But I'll let other people decide how we want to handle it administratively.
My take is, if there's something that no one has an intuition on how to solve, keeping it open I don't see what leads us to closing it. And so I'd rather have us fail. If no one proposes anything, the answer is going to be we're not doing it. And so I would put the burden on whoever, and we're at a point on this document where anyone can file an issue. So if anyone comes up with a proposal, then they open an issue. That would be my personal preference, but if you really disagree, I think we can keep it open. But
No, it's okay. I mean, go ahead and close it if that's what you want to do. I will probably forget about it. We will all forget about it. Probably sometime after we ship it, somebody will report a very complicated bug where we've hit this issue and complain, and then we'll kick ourselves for not having spent more time on it.
okay, all right. Well, so I'm getting a +1 from to what I was proposing on the chat. I'm gonna go with this then. All right, I'll add some text to these issues. Eric, if you want to keep going.
Sounds good. All right, so basically we'll get that in without max data, get some experience with it, see how it feels, and we can go from there. All right, skipping ahead. That brings us to H2, and this ought to actually be fairly quick. So, since 112, we've landed a bunch of the changes that we talked about then. However, a bunch of the changes that we talked about then, the resolution was wait for the HTTP datagram design team in Mask, which has now concluded, so that is fantastic. We are unblocked on that. The remaining outcome from that that we need to decide what to do with is capsules. So that's going to be where I suspect we'll spend the bulk of our time today. Before we do that, there is one other issue that I think Martin filed that is something I wanted to bring up, so we all talk about it a little bit and see if there's any intuition from anyone that would prevent what seems like the right answer to me. Essentially, this is talking about sending frames before you actually get the response back from that initial connect message. So today there's text in the document that says that until your connect gets back a response saying, 200, you're good to go, this is now a web transport session, neither side can send any web transport frames at all. You're stuck for that entire RTT. And I think Martin very rightly points out, that's basically just delaying things arbitrarily. Any frames that you're allowed to send by the flow control limits, et cetera, et cetera. So any frame that would otherwise be legitimate, why should we prevent you from sending them? And so the proposal here is allow sending them. Don't force people to have extra RTTs or, trips as opposed to round trips, and let everything get going a little bit sooner. If you want to wait, nothing stops you from waiting. That can be a nice, simple, easy way to implement it. But if somebody wants to put in the effort to correctly, send frames to allow things to get going sooner, especially since web transport is focused on allowing the server to also initiate web transport streams, if one of the first things that you're planning on doing is having the server open a number of streams, then having it be able to send those frames without waiting for the connect response to get to the client and then for frames to get back from the client to the server so that it can then open some streams seems really very pleasing. So if anybody is strongly opposed to that or sees a reason why we should keep that restriction around, now would be the time to speak, because it seems great to let things get going and not have extra RTTs be there when we don't need them. Excellent. We will take silence as an indication of no major problems. That brings us to the fun part of these slides, for some values of fun, which is capsules. So the datagram design team is now complete. Thank you, David, and a bunch of other fine folk who participated there and helped get that out in time so that we could talk about this here. Previously in H2, we defined TLVs for every web transport frame. And now that capsules are a thing, we could potentially be registering them instead of in our registry of places where we keep our list of web transport frames to use with H2, we could register them in a different registry where we keep the list of capsules. And so that brings up the somewhat obvious question of, great, so what do we get if we use capsules? And this is our current list of frames. We arrived at this a couple of meetings ago. It's basically the minimal subset of things that we need in order to send on the connect stream so that web transport works. If we use capsules, there exists this cool capsule already called datagram, and we could potentially just use that instead of having it be WT datagram. The definition is the same, the wire format is the same, the semantics are essentially the same, with a little bit of caveat that we'll talk about a little bit later. The other benefit here is if we were planning on using any of these other ones like WT max streams and WT streams blocked from H3, having them be capsules that you can just use from H2, you can use it from H3, everybody's happy. That works out pretty nicely. We've just talked about removing web transport max data from that list. So the reuse here on the later part of this slide was previously going to be web transport max streams along with the blocked variant, as well as web transport max data along with the blocked variant. That would now just be web transport max streams, but the point is the same. If there's anything from H2 that we need to reuse in H3, we can just use it. It's great, it's happy. We're in a shared registry already anyway, no problems there. The thing that I think we want to discuss is whether the end-to-endianness of these capsules is going to be an issue. Is that a good thing? Is that a bad thing? And so my understanding is that the TLVs that we were previously defining for your web transport over H2 frames were not end-to-end. They would be consumed by whoever's terminating that particular H2 connection. And if you imagine a scenario where not everybody wants to implement or be supporting web transport over H2, but we do think that we need it maybe on the actual connection over, you know, kind of the last mile of the internet to whatever client is connecting because it may not have access to quick on some percentage of networks. You could imagine that an intermediary would allow a client to fall back to web transport over H2, but still want to speak web transport over H3 to whatever upstream or origin that it's going to be talking to. And it would be doing that for all of its clients. So it would be talking H3 upstream all the time, and it would usually be talking H3 downstream to the client most of the time. But sometimes some of the clients are going to need to fall back to H2, and we want that to work. If we define these as capsules, in theory, they are supposed to transit that intermediary and go all the way to the end. And so the question here is, web transport over H3 is currently defining a whole bunch of capsules. If web transport over H2 is defining a different set of capsules, we've just talked about reusing one or two of them, but in general, it's a not super overlapping set. What is the expectation here? Like when I'm an intermediary going from web transport over H2 to web transport over H3, like does every web transport speaking endpoint need to be able to talk all of those because somebody in the chain might have been using H2 or might have been using H3? So that brings us to our discussion slide, and I will move back one here since I don't think having discussion on the screen is super helpful. Thoughts and feelings. Alan is in the queue.
Alan Frindell. So just to repeat what I just put in the chat, which is that the datagram capsule, it's end-to-end as a concept, but it's not transmitted at each hop as a capsule, right? When you go through a hop, when it came in as a capsule, but the other end supports a native datagram concept, then it's the intermediary is allowed to sort of convert. And so some of the capsules, I don't even know if you want to go back to the slide that has them all, that might make sense, where for example, probably like reset stream or stop sending can make sense in that context. I'm not so sure about the ones that are trying to control resource limits, because those resource limits are very much hop by hop. So I'm probably going to have more to say on this, but I'll stop there.
Yeah, I think that matches kind of my initial intuition, which is that at the very least, the flow control ones seem usefully hop by hop, although end-to-end flow control across a web transport session is an interesting concept, but I don't know that it was the original intent of having those resource limits and allowing an intermediary to share that across multiple people potentially who are sharing the same upstream connection. Martin.
So I think Mark Nottingham's review of the datagrams draft that asked the question, is capsules premature or something or other? Generalization abstraction. And I think it's this here that sort of highlights the challenges of using capsules for anything. Because I think you can relatively simply look at the datagram thing in isolation and go, yeah, that makes a fair bit of sense. We can pull those out and we can forward those however we choose. But then I'm looking at the stuff you're doing with streams here and thinking, if there are connection level constraints on what we can do with streams, the amount of data we can put on them, the number that we can have, I don't know how to intermediate those and take stuff that's on an H2 stream and then lift it into native H3 concepts and then back into an H2 stream again at some other point. I suspect that the right answer here is to not do any of it, because this is just too hard. And maybe it's just because it's 2 in the morning and I'm feeling rather stupid, but I can't conceive of a way of that isn't massively complicated and also likely to fail regardless of what we do and how clever we are. So I'm quite happy with the current design, honestly.
I think there's something to that in the sense that, as Alan pointed out, like there is a way, and Datagram is actually an example of that, where in the HTTP Datagrams document, it says, each capsule type can define the translation that it should do potentially when running over different transports. And the only capsule that is defined also defines one of those to say Datagram is potentially broken out into being a native datagram. So like that concept is appealing, and it's maybe possible to do that for each of these things, but I'm not really sure that that gets us where we want to be anyway.
David Skenazy, speaking as an individual. So I've been thinking about this capsule thing for a while over in Mask Land, and kind of saw this come up and was like trying to, because I agree with Martin, that's what's made Mask interesting, is depending on how you stare at it, everything looks completely different. And I think what it comes down to is is Web Transport over HTTP3 the same protocol as Web Transport over HTTP 2 and 1? Or are they different protocols? And by protocol, I mean HTTP upgrade token, perhaps. Where this gets really interesting is, let's say you have a scenario where you have 2 H2 hops and an intermediary in the middle. You would, like, capsules are great there. You want everything to be end-to-end. All the intermediary does is to shove the stream back and forth, and everything just works. But if you have a case where you have H3 and then H2, kind of conceptually in my mind, you no longer have an intermediary in the middle. You have a server that terminates the client's Web Transport HTTP3 connection, and then it turns around and becomes a Web Transport client over HTTP2 to the backend, for lack of a better word. And at that point, the capsules are end-to-end from the client to the first node and from the first node to the second node, in that you have 3 ends or 4 to this protocol as opposed to 2. That kind of makes it make sense to me. This feels consistent. It actually, like we had another discussion of like should they have different HTTP upgrade tokens? It kind of pushes me in the yes bucket for that a little bit, but that makes it all of this kind of self-consistent and kind of clean and reasonable to me. MT, does this make any sense to you?
That is amazingly slow. That makes perfect sense. I think that the sort of realization that comes if you've got that sort of intermediary that's taking H2 to H3 or vice versa, and you're doing the web transport thing, then that intermediary needs to understand web transport, pure and simple, up and down, back and forth.
Yep.
There are still problems that we don't have solved in that scenario, though. And that's where it starts to get really interesting. If the first hop has no constraints on creating streams, but the second hop does, and you have a stream come in at the intermediary, and the intermediary cannot create the outgoing stream, what is it going to do? Yeah, exactly the sort of thinking that I'm going through, right? How the hell do you deal with that? And the answer is, I don't know. Really, that's the best that I've got right now.
And just to make sure I'm understanding you right, well, first off, I agree. Like that kind of it's a form of back pressure, just 17 different like degrees of back pressure, 50 shades of back pressure, if you will. The thinking about it, though, that like this issue at hand, whether we're using capsules or something, or any possible framing for this, we still have to solve that, right? Like, unfortunately, if you have an intermediary, no matter what, we have that problem.
If it stays in the stream and can stay in the stream, then it's not a problem. If it has to be lifted out and the constraints are different, then that's not going to be the case. So if your intermediary was just tunneling the effectively byte stream back and forth, then that would be fine. I think it wouldn't be constrained in any way, and the constraints on the number of streams that you have would be fully end to end at that point. It's only funny when you start talking about protocol translations and other things.
And so in that case, if we're keeping everything in the stream, then that sounds like a textbook use case for capsules.
Except that it's not buying us anything at that point. Apart from a whole bunch of redundant length fields. And I'll jump back in line for that one.
Yeah, same line. Alan, you're next in queue.
Alan Frindell. When you talked about that stream problem going through intermediaries, it reminded me that we have had that problem with, I'm going to say the P word, everyone cover your ears if you don't want to hear it, push, server push. We had that problem where the one hop thought it could create new pushes, and it got to a proxy that no longer had available streams. So, and it's kind of a hard problem. And in the H2 version of Web Transport, it's very nice because all the stream creation is completely end to end, and or all the stream limits that we have not yet actually defined yet, but plan to, or I guess they're here, will be end to end. But yeah, whenever you're going between protocols, as Martin says, there's problems.
Hello, Lucas Bardi speaking for myself. Yeah, I made a comment in the Jabber. I think, like, my understanding of what Martin said about the stream impedance between creation on one side of an intermediary and the other seems just to be something that exists already today, to me anyway. If maybe if there is a problem, we could solve this with contexts, and capsules would let us do that if we really wanted to. So I don't see a humongous issue here myself. That is different than the problem we already have today.
So I don't have a huge challenge with that. The thing that I think comes up here, which is interesting, is when you're looking at H3 and you're looking at H2, and then we start talking about what you do with upgrade tokens and that sort of thing with H1. Once upon a time, we had a conversation, and I think this echoes a lot of what Martin just said in the chat, which is we talked about kind of, do we define these things that we're sending over the connect stream? And capsules have this cute way to say, you know, it's a datagram. When you're on a transport that supports datagrams, split it out to be a datagram. We could make the web transport stream capsule do the same thing and say, when you're on H3, split it out. When you're on H2, don't. But we have not currently done the exercise of making H3 and H2 use a single list of these things. But there's significant overlap for a bunch of them, and we're talking about reusing a bunch of them where appropriate. Is this just a signal that where appropriate is actually all of them? And once you start talking about intermediaries, or if you start, to David's example earlier, like what if I go H2 to H3 to H2, right? Or what if I'm even going H2 to H2, and we were just talking about how flow control gets propagated there. So there's definitely a line here where it's more complicated, and your intermediary's got to be smart enough to know what it's doing. And like, I'm totally fine saying that there's a lot of these cases that cross that line, and if you weren't smart enough to do it, you shouldn't have been doing it, so stop. But it does almost seem like it's worth doing a little bit of the exercise to see, for the parts that are over H3, maybe those are just defined in the same way and defined to be broken out for H3, and H2 is just those being smushed together, which is the list that we have on screen right now.
Thanks. David in the queue again as an individual. I agree with Eric here. Just wanted to reply to Martin's point, like what is this bias and adding redundant links? So I'm looking at the H2 draft, and it like, because, you know, we have these frames, and I think it's reasonable that we might want to add a future frame for an extension later. These are self-describing, and so we have a sequence of TLVs on the data stream, which starts to look like something I know. So like, we don't have any redundant links. These are literally wire format compatible with capsules. The only question is, do we share types? Is this one INO registry or two INO registries? And for the reason that Eric mentioned earlier, having some of them be the same everywhere and some of them be popped out in quick for there, I think that really meshes with MT's original point of, we're defining a generic web transfer of HTTP, and then when it's over H3, you can put it on steroids. It can do extra cool stuff. So like, this is starting to make a lot of sense to me personally. Go ahead, MT.
Yeah, the problem that you don't get any real performance guarantees. So you might attempt at one point to get true datagrams for your datagrams and true quick streams for your quick streams, and then further down the chain, that's not the case. I was going to say there's probably a simpler way of building this, and it may not be as pleasant, but don't do that is actually a pretty good strategy. And if your intermediary doesn't need to do, doesn't advertise support for HTTP3 version of web transport, if it cannot guarantee end-to-end quick and HTTP3 all the way, I'm losing my brain. It's really good at this time in the morning. If it can't guarantee end-to-end, then it doesn't offer it. And the fallback here, which is the H2 one, which by the way probably works on HTTP 1.1 as well adequately, then that's your fallback. The way in which we get streams lifted up into the quick streams is would require a whole lot more unification between the designs of the quick and the HTTP2 and the HTTP3 versions of this.
Thanks, Eric.
Yeah, I'm kind of wondering if it's worth doing that effort. It's tempting to, sit down for an hour or three and see how far we get with it. It may be that we get there and we're like, great, this is actually not that hard. These things weren't really that different. The current H3 document is basically defining a capsule that has a way to be broken out for H3 by default already. Or it could be that we get partway into that and say, no, this is terrible. They're separate for a reason. They should stay separate. But there does seem something reasonably attractive about having them share the same thing, and then web transport over H3 is broken out, and we just choose to not define a way to break them out into native H2 streams because we don't want to deal with that, and then we're all happy and it's done. The only other point that I do want to make, David, when you say that using a capsule is a choice to put this TLV in a different IANA registry, I think that's absolutely true. But when we're looking at the other things that we get from that, I think is our litmus test for should this be a capsule, should it be end-to-end or not? And if not, what is the litmus test? Because I think which IANA registry do we want it in is, that's nice, and I'm happy, I don't care what IANA registry we put things in. But it seems as though if we're like, great, this is nice, we can put it in a different IANA registry and now we don't have to make a new one. How pleasing. That is pleasing, but if that comes with this extra end-to-end property that is actively harmful, it seems like the litmus test here is the third item on this slide, not the first item on this slide.
Yeah, fair enough. I agree with that. It's looking like we've drained the queue on this one, and having seen the slides, we don't have anything after this. So clearly we don't have an obvious answer, definite consensus on this one, but it's worth, I like Eric's plan of trying it out and then showing, having MT look at a PR from Eric when MT has had a decent night's sleep and see if he likes it or not would be a good next step. And of course, to have the entire working group take a look or contribute to that. How does that sound like a good path forward here so we can make progress? I see Eric in the queue. Go ahead.
Yeah, I'm certainly game to do that, and happy to do that with other folks if we want to sit down together and talk about it on a call somewhere and brainstorm a little bit while we do it. But yeah, the other thing, just in case Victor wasn't looking at the chat, I know we talked about this a little bit before, but I wanted to make sure if any reaction there, since a lot of what we're just discussing kind of has impacts for how H3 looks. I know this had come up in the past. If there's anything that we want to think about there that we might be missing, it would be good to hear about that at some point as well. Doesn't have to be right now, but worth thinking about.
Thanks. And I think having a call sounds like a good idea with the most passionate folks to move this forward. I'm debating whether I want to use the term design team or not. I'm realizing that the terminology doesn't matter too much. Do folks have thoughts? All right. Alan says if it does walk like a design team and quack like a design team after all. Okay, we shall be forming a design team. So I will send an email to the list asking for volunteers. Eric, since you've been kind of leading this and offering to do the PR, would you be willing to lead this design team?
Sure, you do.
Thank you. So we'll send an email to the list, and if you are interested in joining, please reach out to the chairs, and then we'll have the design team figure this out for us. And in an ideal world, if that would happen in the near future, we could have an interim to discuss it. Similar to what we've been doing over the last 3 months at a very different working group. Yeah. Bernard, any thoughts? I'm starting to think like I'm rambling, and we can probably end the meeting early at this point pretty soon.
No, I think we've hopefully overcome the note-taking problem. You should see the notes in the coming up very soon, and it sounds like we've got our next steps.
Indeed, yeah, I do see the minutes now. Thanks for clearing that out. I do see Jonathan Lennox in the queue. Come on over.
Yeah, Jonathan Lennox. This is Luke Curley, who said he missed the initial priorities discussion, raised an interesting point in the chat, since we seem to have run out of everything else to talk about, that he has a mock style scenario where he wants to be able to prioritize new things he sent over old things he sent, which is hard to do with a small fixed set of priorities. So I guess I know the priorities API is not in scope of this working group per se, but it's something to people who are designing mechanisms like that to keep in mind. Like whether that means, I mean, it sounds like his implementation just has, you know, a uint64 for priority and just names his priorities after his stream IDs. That's one possibility, or you have could have some way of dynamically adjusting priorities of older stuff or something like that. That's just something to keep in mind.
Okay. Speaking as chair, since we do have another 30 minutes, it makes sense to use this in-person time, so I'm okay with that. And I see Luke in the queue as well, so let's just go through the queue. Alan, go ahead.
Alan Frindell. Well, I was going to raise a different point before we jumped into priorities, but since
go ahead.
I'll just talk about the priorities and then make my other point too. So I think in terms of Luke's scenario, you don't if you really all you want is to switch, you know, your mode from FIFO to LIFO, maybe the easiest way to do that is have a single message that goes over your web transport application protocol that says, please use, you know, please tell the scheduler on the other side to do everything in reverse stream ID order, and then you're rather than juggling your 8 lanes or whatever. So that may be a possibility that could work. The other point I wanted to make was something that came up right at the end of the media over quick session that had me thinking about its intersection with web transport, which is in media over quick, you know, I think we recognize that we can get quite a bit of, you know, value out of breaking videos up in a certain way and sending them over quick streams. But that if you want to push latency really low, and I'm not going to get into discussion about what is low latency, but if you want to go as fast as possible, at some point you need better interaction with or closer ties with congestion control, loss recovery, retransmission policies, introspection from the lowest level of the transport in terms of you know, information it might have that you want to feed back into the application, a really tight coupling. And I personally have not been very involved in the W3C API definition for web transport. So, and I saw there's like web transport stats, which maybe have some of that feedback. But I wonder if, as Mock is starting to get going, and some people have dreams of someday building that in web transport, you know, are we going to think about a, you know, sort of V2 version of the API that's got, you know, more sophistication there? Thanks.
Okay, thanks. That sounds useful. This topic has definitely been in the biggest queue size we've seen in this working group. So just to be clear, this is not the mock buff, but we can please. So yeah, we can talk about this, but let's scope it to the implications to web transport. And on your other point, yeah, I encourage you to join the W3C sessions for there. I forget the details about membership in the W3C, so double check those. But we've had good conversations around those things, and from folks who really care would be useful. And okay, Luke is next in the queue.
my name mentioned. Yeah, just to summarize the priority stuff. It's something that right now it's fine because I'm sending. I have a server, and at the server you can prioritize quick streams. But it is something that you eventually need browser support for. Is the idea that we want to fully use the connection, and we want the connection to degrade cleanly when the window it's out of bandwidth effectively. So yeah, the gist of Warp is nearer segments and audio are higher priority. So it's kind of like a LIFO, although it gets more complicated than that. To some people saying you could just switch the mode. Stuff like control messages still need to be on a higher priority stream and whatnot. But I agree, this is something that's not really the transport doesn't need to support. But we do need a way for endpoints to tell other endpoints, like, this is the priority of this stream. Like, I created this stream. Could you please write back to it with this priority? Is effectively what we're looking for, and that can be accomplished with like an HTTP header. Like Luke is the extensible priority header. Yeah, a little bit of signaling is probably needed.
Thanks. That makes sense. Victor?
I think I just wanted to encourage people who have opinions to comment on the W3C issue, which is issue 62, and I posted the link in chat.
Thank you, Victor. MT?
So I guess it was a little unclear from the description there, but it seems like this is mostly something that the application can do for itself, because you're having the client tell the server to prioritize in a particular way, which I guess means that your signaling can be worked out on your own terms. There's nothing here that's impossible, because anything is possible once you give someone the ability to send bytes to another one. I was wondering whether there was any requirement from the browser side from their application. So you're creating multiple streams on the browser end and trying to send on them. Is there any requirement that those be LIFO in terms of the sending behavior of the browser? That would be more interesting in the context of this one, because that's not something that you can change. Obviously, you sort of control your service. You don't really control what the browsers do.
Thanks. And yeah, jumping in as, oh, sorry, go. Okay, just jumping in as chair. Yeah, I think that's a great place to kind of draw the line for, like, our goal for web transport has been to ship something that works, at least for now. And in terms of scoping it, like, if something can be solved at the application layer, kind of our philosophy has been to just keep it there for now. And perhaps at some point, if we realize every other application is doing the same thing, like, for example, we talked about messaging framing, then we might consider adding it to, like, web transport v2, whatever. But yeah, that seems like to be a good demarcation for what we consider in scope. Just some thoughts. Lucas, go ahead.
Hello, Lucas Bardu speaking. Yeah, like, obviously this topic is super exciting for me. I'm not that worried, because, like, the external priorities draft is just one kind of signal, and it's intended to be used in one way. And in practicality, it should definitely be combined with all the other information any sender is using to schedule how stream data or datagram data is being sent. Some might ignore it, some might use it, some might use it more strongly than other inputs. It seems like web transport has all the pieces there to let us add extra signals, or to provide some guidance on how those signals could be used slightly differently. I think the browser world in particular has a lot of constraints that others don't. In the quick world, we say, we should provide an ability for applications to control the prioritization of stream data, as an example. And then we leave that completely undefined. Some people hate that, but it works okay for now. And we'll use these things and we'll figure some more stuff out. And maybe in a V2 or some other additional document, we can address this. My main concern is, are we blocking anyone from being able to extend or innovate or address the use case that they want? And I don't think that's true. So I think we're in a decent state, and I'm more than happy to continue following the discussion and seeing what we can do to make things better.
Thanks, Lucas. Hey, Colin.
So I just wanted to jump all the way back to the priority issue. And I do think that it'd be very desirable to have some way to be able to deal with, saying the sequence that the web transport is going to be sending things out of the browser. That seems pretty important for a lot of use cases, particularly the ones Luke was talking about. But I don't think that I think that for a lot of them, just saying a LIFO doesn't necessarily work. Even in the case, the video case, I think you run into problems where it works. It makes it a little bit better on semi-congested networks, but as soon as things get a little bit the next level of worse, that LIFO mechanism totally fails without an actual prioritization scheme. So I think it'd be well worth us talking a little bit about something more flexible that meant a broader set of use cases for how to do prioritization.
Thanks, Colin. Bernard?
There. So I'm talking with my IETF web transport hat off, but I will just say that in terms of W3C work, we now have a functioning version of web transport API as well as web codecs in Chromium. And so some of these mock scenarios, you can actually build them in a fairly little amount of code. But one thing I'd like to make clear is that as I see it, I believe, and maybe Alan can correct me if he's tried this, that the video upload scenario should be implementable using the Web Transport API as it exists today. The downstream scenario is a little bit more complicated, but the key thing to understand here is in that scenario, as has been described, the server can do things like priority, assuming it's available, without the Web Transport client having to support that. So at least within the API scope so far, it doesn't seem to me like, it seems like the current API can at least accommodate those two scenarios, the downstream and the video upload. Of course, we're very willing to understand if there are issues doing that, and I would urge people to actually try it out. So, you know, we very consciously didn't try to go down to the lowest levels in the API like you originally thought. Do people need access to the ACK info or the guts of quick bandwidth estimation? And after some debate, we said not really. That's turning out to be an issue for RTP directly over quick, but hopefully not for most of the mock use cases. And the stats that are there to make clear to people, they're not so you can implement congestion control. They're just there really to give you a sense of how well your app is performing. But I'd urge people to try the APIs out and see if there are any issues.
Magnus Westland, in the priority here, is it question if you actually need to have dynamic or is it update the priority value for a transmission, so to say? Is that part of the problem here, really? I wonder if it's not, or you're assuming that you have so small data blocks that you're sending one single datagram and that's the only thing you need, or?
Just out of curiosity, who are you asking the question? Because obviously, no one's on the screen, so you're looking at me, but I can't answer. I don't know.
No. I asked in the working group, I think, about if it's.
Well, Luke's next in queue. Maybe he can attempt to answer, because I know he's thought about this quite a bit.
Yeah, so I wanted to also answer Bernard. We're doing it. We're actually, right now, Twitch is using Web Transport. I think it's like 1% of Chrome users right now. We're not using web codecs, we're using MSE still, but I have a player that uses it. And yeah, we are doing prioritization on the server side. It is currently the current design, to answer the previous question, it is a fixed, when the stream's created, we know the priority. It doesn't need to change. Although, in theory, you could make a slightly better design if it's allowed to change. It really just depends. There's no right answer for prioritization. So it's nice to have that functionality, but it's not required either. I think for Bernard, the main concern is, and this is a W3C thing, is just if you want to switch the direction, if you want to create media at the browser and push it like via warp or whatever to the server, you can't control the priority then, and that's something that we're thinking about. Like, how could you do ingest and send newer media before older media, so you can just starve and eventually drop the older media?
That would be interesting to see your results and concerns about that. As you said, it's the client sending that's the real problem here.
Alan Frindell. Yeah, I think just responding to what Bernard had said when he was up last time, just that I'm thinking about the same scenario that Luke is talking about, but also probably not going to be in the early scoping of mock, so probably maybe not so urgent. But I just got the sense that there were people in the room who have very low latency use cases for sending video, and probably weren't going to be happy with like the default quick congestion control that the browser was providing. So again, it can be a long-term thing, but I think for the shorter medium term that we might want to do there, it's probably going to be fine.
Thanks, Alan. Bernard?
To follow up on what Alan said, Alan, I'd be very interested if, in particular, if you're encountering any issues with BBRV1 in your video upload scenario. I don't know if your quick implementation you were using did BBRV1, or I don't think that same problem would occur with new Reno, but.
Sorry, Luke, I just jumped the queue to respond to Bernard, which is, I just want to be clear that I personally, and I'm not sure that Meta either does have any code that does this right now. It was just based on sort of the comments and discussion that happened on Wednesday. So if I have running code and I have problems, I'll let you know.
Okay.
Go ahead, Luke.
Just to reply to that, I've implemented BBR V1. I also tried V2, but there's some bugs. I haven't fixed those yet. Most of our concerns with it are theoretical at this point. We're not really pushing latency low enough that the probe RTT phase is an issue. And you're right, like Reno and Cubic, they don't really have the same latency concerns, but they also kind of congest a lot easier. I think eventually it would be nice to have more control over congestion control in web transport, but I think that's probably asking a lot. I'll be honest. I think that's probably asking too much for browsers to say, like, let me control the fine-grained when every packet should be sent. But I think that's up for discussion, and certainly a W3C thing. How much control should an application have over when individual packets are sent?
I think that maybe the level that you might want to consider at some point is that there's some sort of hints that can be passed on down about the congestion control that's used at the quick layer, but we're probably not anywhere near that point yet. But it probably at some point we probably will be at that point, and we might want to think about whether you're going to directly control what quick uses, or whether you're just going to pass down some hints about the attributes of what you wish about your desired performance. Right? And I don't really care, as long as there's some way to influence it.
Just to respond to Cullen, that's kind of what's been proposed in the API. It would be some hint in the constructor that would tell you what kind of CC you want.
Yeah, exactly. I mean, I don't see what that seems adequate for what I can imagine right now is what's there right now. So like that's why I haven't raised any issues. It seems fine.
That was a nice screen freeze. Victor?
Yeah, I think both variants about for congestion control are possible. My idea was the simplest one is like we would have an enum which would let you switch between something like BBR and something like, I don't know, GUCCC, or any other real-time appropriate algorithm, but it is not entirely infeasible to hand off congestion control to JavaScript. I've seen at least a research project, that is to say, I don't know if they ever published a paper, but they had a working prototype to move congestion control out of Linux kernel to user space, and that was roughly like cross-process out-of-process congestion control. So this is definitely possible, and is even something that people have done before. And the question would be, is it really worth of engineering investment at that point?
Yeah, I guess to Victor's question, it's probably worth discussing at some point how you could figure that out. I mean, I guess the first step would be for people to do their own thing and see what works and what doesn't work, and have some evidence. Right now, I think Victor, there's some people working on Scream, and I think they've had some results that suggest that something like Google CC or Scream might be worthwhile. But there's also the issue of, particularly if you're doing weird things like pooling, like what would happen there, it may not be that simple.
All right. It appears we have drained the queue. Unless folks have other things, I think, and we're getting closer to time, I think we're going to wrap this up. Thanks everyone for coming. Thanks to the presenters for taking the time to make slides and to present. I think we had a very productive session today. We got closer to resolving quite a few issues, and we're starting a brand new design team to address a thorny one. I think we're making good progress to getting these documents close to something very stable, which is great. Thanks everyone for that. Thanks everyone for always making sure this working group is a fun and polite, pleasant place to work. So thanks. And we'll see you on the mailing list and potentially at an interim, assuming the design team reaches something in the near future. Thanks and bye.
Yes.